Yesterday, 6 people flew to suborbital space and back, and one of them was a researcher. Yes, the majority of people who fly on suborbital space flights are joyriders, but there is legitimate science that is being done in suborbital spaceflight with human-tended experiments. I am speaking about the Blue Origin mission yesterday, NS-26, that flew with Rob Ferl. He is a professor at the University of Florida, and he flew a research experiment in space which he conducted during his Blue Origin flight. And you might be thinking, suborbital space isn't real space. They did fly over the von Karman line. That's the 100-kilometer line, but they flew to an altitude of about 104 kilometers. Yes, for only about 5 minutes, and came right back down where they started. That 5 minutes was enough time for Rob to do real science in space. But I do want to talk about how suborbital human spaceflight has not really lived up to the potential that was expected compared to orbital spaceflight. And here I'm talking about commercial providers. So Blue Origin, Virgin Galactic, they have not really done what we in the scientific community had hoped that they would do compared to providers like SpaceX. But that doesn't discount what they are doing, the fantastic work that can be done and is being done in suborbital space. Yesterday morning in Texas, I don't know if you can relate, but when you know somebody on board, you get a little knot in your throat. So that was me. I was excited and nervous for Rob. Not that I expected anything to go wrong, but it's one of those things where you just never know. I am Laura Forsick. I'm the executive director of space consulting firm Astrolytical, and I have been involved in the suborbital spaceflight community for almost 15 years now, since that very first meeting was held of the Next Generation Suborbital Researchers Conference back in 2010, which may or may not have been when I first met Rob Ferl and Annalisa Paul of the University of Florida. At that point in time, there were no humans flying to suborbital space. At that point in time, the suborbital spaceflight providers were still very young. There was still X-Core, for example. But back in the day, there were opportunities to send payloads on some of those early missions. In fact, when I was a graduate student at the University of Central Florida, I worked in a laboratory where we were actually preparing experiments to fly on one of the earliest Blue Origin uncrewed flights of New Shepard. I was thrilled to see the news earlier this year that Rob was selected to fly as the first NASA-sponsored researcher on a suborbital flight. You might remember back in November of 2023, Alan Stern and Kelly Girardi, both colleagues of mine, they flew research on a Virgin Galactic flight. I had known about their space flights for a while, so I actually interviewed them for my book Before Their Space Flights. Alan has been selected for a while as a NASA-sponsored researcher, but for that particular Virgin Galactic flight, he did not fly as a NASA-funded researcher. He flew in preparation, sponsored by his employer, Southwest Research Institute. And Kelly Girardi was also sponsored by an organization, and she's planning to fly again with 2 other colleagues of mine. So super exciting time to be a researcher who can fly with their research in suborbital spaceflight. It might surprise you that the experiment that was flown yesterday on Blue Origin with Rob Ferl was not the first time that experiment was flown as a human-tended payload. So the very first human-tended research experiment on a suborbital flight was actually done on a Virgin Galactic flight by Sarisha Bandla. Sarisha is a Virgin Galactic employee, and on behalf of the University of Florida team, she actually did the experiment in space during her suborbital spaceflight in 2021. Rob and Annalisa both helped develop something called KFTs, and what's typical with space is that we have an acronym within an acronym. That's KSC, Kennedy Space Center Fixation Tubes, KFT. I'm a physical scientist, not a life scientist, so I'm going to do my best here. But basically, those tubes, when you push in the plunger, it sort of freezes the plant where it is in that moment in time to be studied later. And they were trying to understand how gene expression happens in the cells of plants as they undergo the stress of transition from 1G here on Earth to a high G, that's the launch, to microgravity. So even though plant science has been studied extensively on the International Space Station and other space platforms, what has not been studied is this transition period, the stresses that the living organism goes through as it transitions from normal G to high G to micro G. So several of these tubes were brought up. I think 3 on Virgin Galactic. I don't know how many on the Blue Origin flight yesterday. And they froze those plants in time, in a sense. I don't know if they actually froze them, but they stopped time for those plants during key periods of the transition. And then they have control on the grounds. They have plants that they do the same thing at the same time in 1G that's not undergoing any stressors at all. One of the promises of human suborbital spaceflight from back in the day that hasn't really come to fruition, although this might be the beginning of it, is the ability to iterate on your science fairly quickly. So Virgin Galactic flight happened happened in 2021, Rob and Annalisa and their team at UF were able to then iterate upon what they learned from the results of that first spaceflight to then improve upon or get different results from this flight that they took yesterday on Blue Origin. And because a scientist flew with his own experiment, that adds a level of comfort and familiarity, and even the ability to adapt on the go if need be. Astronauts who are on the International Space Station, they tend to be trained by scientists. They tend to not be doing their own science, with few exceptions throughout history. So this is a period of time where suborbital spaceflight is less expensive and was promised to be more frequent. And therefore, the idea was that scientists could fly with their own experiments. The researchers could do the research in space, and they would be able to iterate and fly it again, which now we've seen with this UF experiment. We will hopefully see with Alan Stern and Kelly Girardi and others. It's not all plant science, by the way. So when I was a graduate student, the work that I was doing that was flying uncrewed on these suborbital flights was what I call experimental planetary science. So trying to understand how planetary bodies were formed by doing very, very slow impacts, very low energy impacts in a microgravity environment. Other researchers have been doing other types of uncrewed suborbital experiments as well. I will put the link below to the Next Generation Suborbital Researchers Conference, where you can see some of the experiments that have been presented. One of the major challenges of suborbital spaceflight in general, and human-tended suborbital research in particular, is the very short amount of time that you have when you've got all these other things going on around you, and you want to factor in time to look out the window. Believe me, that's been talked about a lot. Every scientist that goes up there factors in some time where they require themselves to look out the window to experience the view, to experience the awe of being in space. Yesterday, during the live stream, after the crew landed back in the desert in Texas, Rob did have something to say about how the experiment went.
The ride was incredibly smooth, and I was so impressed with the ride up. But being there, the darkness of space, there's no way to talk about it. There's no way to talk about how impressive space is and the Earth below.
Clearly,
well.
So staying tuned for that after the mission.
Everything worked the way it was supposed to. The hours, weeks, and months of preparation all went real well. Everything is good.
That's great.
Couldn't have been a better experience.
He was the only scientist on that crew. The rest were joyriders, space tourists if you prefer, which, I can't fault them because I would totally do that too. But I do want to talk about how the reality of today does not match the promise of what we did expect 10, 15 years ago with suborbital human spaceflight. The idea was that these flights, these Virgin Galactic flights, these Blue Origin flights, would be happening so frequently and with such a regular cadence. Scientists would be able to do their research in space, analyze their data on the ground, book another flight, and go back in a fairly short period of time. And that has not really happened. Suborbital space does have something going for it in that it is less expensive than orbital space. However, because of the success of SpaceX, which is unparalleled, we do have more access to orbital space for humans than anybody could have predicted a decade ago. SpaceX is not only flying regular crews to the International Space Station for NASA, they are also flying private crews through Axiom Space to the International Space Station, and they are flying private crews on free-flying Dragon missions, and soon in the near future on Starship missions. There might still be a market for suborbital human spaceflight for tourism purposes and perhaps for research for particular types of research like this. My prediction, and I could be totally wrong, but I do think that human orbital spaceflight and doing science in space and orbital space is going to be the more preferred option than human suborbital research. It will definitely be interesting to see how this progresses over time and how the industry is able to accommodate these types of researchers. What is a very interesting turn is that private astronauts, space tourists who are flying to the International Space Station for the fun of it, who have days to themselves to do whatever they want, they are actually voluntarily doing science research for other organizations, for other scientists. And if you're interested in that, go ahead and watch this video next.